So integrating logarithmic functions is looking at the reverse of differentiating them. And the important thing to be able to recognize is firstly that it is going to integrate to a logarithmic function. And the way to recognize that is that any algebraic fraction for which the numerator is the derivative of the denominator, that means that they will integrate to give a natural logarithmic function. So the first step is having a look. If you've got a fraction, the first step is looking for, is the derivative present in the numerator of the denominator? Okay, so we've got here that if we do the integral of 1 on x dx, we get the natural log of x plus c. And if we have if we integrate something where the derivative is the numerator and then you've got the denominator, then we would end up with the natural log of f of x plus c. And these are only for the values of when x is greater than 0, which is what this course is about. So if we have a look at our first example, it says find the integral of 5 over 2x dx for x is greater than 0. So the first step is to understand that we've got a algebraic fraction here, and we're going to write down that we need to rearrange this because we're looking to see the fact that the derivative is partially present because it is just a constant. So we need to rearrange it so we end up with something multiplied by the integral of 1 over x dx, because the derivative of this thing is 1 on x because we're looking for the natural log function. So if we need to get it back to 5 over 2x, it means that we're going to need to multiply this entire integral by 5 over 2, which is what I've written here in the green. Remembering that that number that we bring out the front of the integral sign can only be a number. It can't be a letter, it can only be a number. So it could be a fraction, it could be a whole number, etc., but it can't be letters. Then what we need to do is we'll end up with 5 over 2 times, and 1 over x integrates to being the natural log of x, and then we have plus c on the end. So we've really got 5 over 2 natural log of x plus c, and that could also be written as 5 natural log of x over 2 plus c. The next one is looking at the integral of 10x over 2x plus 1. So the first thing we need to know is we note the derivative of the denominator. So derivative of denominator is 2x. And you can see that 2x is present in that 10x there. So what we need to do, again, we need to multiply the integral by something, but I'm going to make the fraction now 2x, which is what our derivative is, over x squared plus 1 dx. And we, again, look at what do we multiply 2x by to get it back to 10x. And that should be 5. So we put the 5 out the front. And then if we integrate, we're going to integrate the 2x over x squared plus 1. That's going to integrate to being the natural log of x squared plus 1, because we're looking at this as a chain rule type question. And of course, we've got the 5 times the natural log of x squared plus 1 plus c. So again, we just write that as 5 natural log of x squared plus 1 in brackets, and then plus c on the end. Example 3. Find the integral of 16 over 2x plus 5 dx for the denominator being greater than 0. So again, we look at our derivative. So the derivative of the denominator here, derivative of denominator is 2. And we know that it is present because we can make 16 using 2. So again, we've got to multiply the integral by something. So we're going to have the integral of 2 over 2x plus 5 dx. But we need to get it back to 16. So what do we multiply 2 by to get it back to 16? It would need to be multiplied by 8. So then we would end up with 8 times the natural log of 2x plus 5, because it's the f of x is the denominator. And then, of course, we have to put the plus c on the end. So again, I just looked at to see what the derivative of the denominator is, and can we make that by multiplying it by another number. So part B for this one is the integral of 15x squared over x cubed plus 1. Again, the derivative of x cubed plus 1 is, so derivative of denominator is 3x squared. So again, we set it up where we have a gap and we multiply the integral of 3x squared over x cubed plus 1 dx. Now, what do we need to multiply the 3x squared by to get it back to 15x squared? Well, it would need to be multiplied by 5. So we would then have 5 times the natural log of x cubed plus 1, because remember, it's the denominator that goes in the brackets. And then, of course, we have to add c at the end. So again, you're just looking at what the derivative of the denominator is, and then putting that as the numerator, and then working out what did I need to multiply that numerator by to get it back to what was in the question. And then we integrate using the denominator as the f of x function after the natural log. And then, of course, doing the integrals and being able to integrate helps us to find the area between curves or area under a curve. And we're just going to do one of those examples. And what we're going to do is we're going to actually leave it as an exact value, so in logarithmic terms. So it says find the area between the x-axis and y equals 1 on x from x equals 2 to x equals 5. So the first step, remember, when you're doing an area calculation is to just view the graph on your calculator or just make a little sketch. So you can see here, I've just done a little sketch. I'll just change the color actually. So the sketch of what the graph looks like is in red here. So this is our 1 on x graph. We've got a reciprocal function and we're looking for when x is between 2 and 5. So I'm just going to shade that area in there. So you can see it's all above the x-axis, so we don't need to use absolute values or anything. We're just doing a definite integral. So to find the area here, I'm just going to write here a equals, it's the integral between 5 and 2 of 1 on x dx. And now the integral of 1 on x, knowing that the natural log of x function differentiates to 1 on x, suggests that we have the natural log of x, and then of course we actually need to sub in that 5 and 2. So we would have the natural log of 5 take away the natural log of 2, and of course using log laws here, if we have a subtraction of two logs that are in the same base, we can actually write that as the natural log of 5 on 2 units squared. Now, you could simplify that to the natural log of 2.5 units squared if you wish to. Otherwise, you can leave it as a fraction. Either of those would be acceptable. And you could potentially also leave it as just the natural log of 5, take the natural log of 2. But because you have learnt log laws, you should be able to apply them to simplify any questions like this. So again, the biggest thing with integrating when it comes to logarithmic functions, you just need to firstly look, if you get a fraction, is the derivative of the denominator present in the numerator? And then if it is, you just rearrange that, work out what that constant is that you're going to multiply the entire integral by, and then integrate by putting the denominator as the inside function when you integrate. And again, it can be used to find the area under a curve or between curves in exact values, actually using those logarithms as they are.